Hello viewers and welcome back to my channel. In this video, we are going to be talking about introduction to complex variables. Okay, this is our first video on this course. This is second year, first semester or second semester course. Okay, now let's start with the foundation, which is complex variable. Complex number. Though I have a full video on complex number, you can watch it, but I'm going to do some recap on the things you need to know before we move into the main thing, which is complex variables. Okay, now what is a complex number? Well, a complex number is a set of numbers that has both the real and the imaginary part, as simple as that. So a complex number is any number that has the real and the imaginary part. Okay, so we represent a complex number as let's say C is equal to a set of A plus BI, such that A and B are elements of the real number. Okay, and then I is equal to the square root of -1. So this is how we define complex number in building form. Okay, I hope you know that this is a building form representation of a set. Okay, so a complex number is any number that has A plus BI, such that A and B are elements of the real number, and then I is equal to the square root of -1. Now, let me take you back to geometry. Now, whenever a set of number or a point, whenever a point is written as maybe A comma B like this, A comma B. Now, we know very well that this A represents the x-axis and then this B represents the y-axis. Okay? Now, in complex number, this one that represents the x-axis is what we call the real part, while this one that represents the y-axis is what we call the imaginary part. So if I want to represent this number in a complex number, I'll call it A, the real part, plus what? B. Then I want to add I to it. This I added shows that this part is called the what? The imaginary part. Okay? So take note of that. So anytime you have a coordinate of anything, just know that that thing is comprised of the real and imaginary part. So if I have -3, 2, for example, so -3 is the real part and then 2 is the imaginary part. Okay, so this is -3 plus what? 2i, if you want to express it as a complex number. Okay, so that is that. Now the next thing we're going to look at is Argand diagram. Now, Argand diagram is a way of representing. In fact, some people say that, okay, if you don't want to represent it this way, you can say that normally we represent a complex number with z. Z is equal to what? X plus what? Yi. Have you noticed that this side that is x, like I told you, is the one that is standing at the real part. The one that y is the coefficient of that I, which is the imaginary part. So this one is the real part, this one is the real part, and then this one is what? The imaginary part. Okay, so that is that for a complex number. So that will now lead us to what we call the Argand diagram. Now, Argand diagram is a way of representing your complex number in an xy plane or the Cartesian plane. Okay, so Argand diagram. So you should write that Argand diagram is a way of representing a complex number in an xy plane. For example, if I have maybe a complex number z is equal to 3 plus 2i. So you're going to draw your Cartesian plane. That is your xyz plane. This is my y, and then this is my x, your xy plane rather. So now let's say that the y, remember that this is always x and then this one is y. So my x is 3. Let's say that here is 3. And then my y is 2. Let's say that here is 2. So now, if here is 2, this comes this way to join this one this way. Okay? So now, the 3 plus 2i is just to draw a line from the origin that passes through that point. Just draw a straight line from origin. Don't mind my own. A straight line that will pass this way. So this line drawn is what we call our the 3 plus 2i. Okay, this line drawn is what we call the 3 plus 2i. So, for example, another example is maybe we have that z is equal to maybe -3 minus 2i. So that means that minus 3 minus, or let's say minus 2 minus 3i, so that it will not always look like that. So minus 2 is for the x-axis. So let's say that this side is our minus 2. And then minus 3 is our y-axis. Let's say that here is our minus 3. So you see that if this one comes this way and this one goes this way, see that they meet here. So this is just joining this straight here. So this is what we call our what? Minus 2 minus 3i. Okay, so Argand diagram is a way of representing a complex number in an xy plane. Okay, very, very important. Now the next thing we'll talk about is you are seeing all this I. Then you'll be thinking, what is the meaning of this I? Okay, so let's talk about that I, the meaning of that I. Now that I is called iota. That I is called iota. Okay, so note that I is called iota. That's the imaginary part. So let's talk about that iota. Now, this I, where did it come from? Now, it came from a problem when mathematicians like us had a conference. So, and then we are asked to solve x squared minus 1 is equal to 0. I do tell students this story. Okay, I was sitting and then they asked me to solve this. Immediately I rushed it and I told them that the answer is x squared is equal to 1. Then x is equal to what? Plus or minus the square root of 1. So x becomes plus or minus 1. Okay, now that same person, I think Professor Chidume, yes, the late Professor Chidume, he was beside me. So he now said, Master Toka, kinesmatics, please change the sign in the middle and solve it. This thing happened in 1802, yes, if I can remember. If you say that I was not born by then, I don't know for you. But I think it happened in 1802. Is it 1802 or 16? Oh, sorry, it happened in 1203. Yes, 1203. Yes, okay. In the year 1203. So he now said, please, I should change the sign in the middle and solve it. Okay. I said, okay, no problem. I now had x squared plus 1 is equal to 0. So x squared is equal to this one moving here, have minus 1. So x becomes, take the square root of both sides to have the square root of minus 1 plus or minus, don't forget. Now x become equal to, now what is now the square root of a negative number? That becomes a problem. I don't even know it. We are thinking about it. All of us, we are putting head together to know how we're going to get the square root of minus 1. Even you yourself, if you point calculator now, square root of minus 1, it will give you math error, okay, or syntax error. But we couldn't find it. And they say that nothing is impossible. Why? Because whatever you cannot find in the real world, you will find it in the imaginary world. So we say, since we cannot find the answer in the real world, now that means the answer is in the imaginary world. And the first letter of imagination is I. So we'll now say, let the square root of negative number be now I. So we now have plus or minus I. So anytime you have the square root of, for example, square root of 4, you will know that square root of 4 is 2. Square root of that minus becomes I. So anytime you have the square root of a negative number, I must come in. So if I have the square root of 2, for example, square root of minus 2, for example, I know that 2 does not have square root, so I will leave it as square root of 2. But I know the square root of minus. Square root of minus is what? I. So take note that I is equal to what? That's how we got that what? I is equal to the square root of minus 1. Okay? So take note of that I is equal to the square root of minus 1. So the I is called the iota. And that is what brought about the studying of a complex number. Okay? So now, since we know that I is equal to the square root of minus 1. If I square both sides, it means that I squared is equal to what? Minus 1 itself. So take note of that. I squared is equal to what? Minus 1. Now what about I cube? I raised to power 3. Now I raised to power 3 is something as saying we must express it in terms of 2. I raised to power 2, 3 is something as 2 plus 1. Okay, I raised to power 2 plus 1. And according to indices, we know that separating this plus, it will be I raised to power 2 multiplied by I raised to power 1. And then I raised to power 2 is equal to what? Minus 1. Then multiply by I. So which will give you minus I. So what about I raised to power 4? I raised to power 4 is something as saying I raised to power 2 multiplied by another 2, which will give you, I know that I raised to power 2 will give us minus 1, then all squared, which will give you what? 1. Okay? So what about I raised to power 23? I raised to power 23 is something as what? I raised to power I raised to the power 2 times 11. I know that 2 times 11 is 22, right? Then plus 1. So which will give you what? I squared. Now raised to the power 11 multiplied by I raised to the power 1. If you separate it according to indices, it will be I raised to the power that 2 times 11 multiplied by that I raised to the power 1. Okay? So which is, I know that I squared is what? Minus 1. Then raised to the power that 11 multiplied by I. So which is what? When the power is odd, the minus will remain. So this is minus 1 multiplied by I, which is giving us minus I. Now, if you look at this, it has a pattern. The pattern is that if you notice, you see that the only answer you will be getting is what? Is either you get 1 or you get minus 1, or you get I or what? Minus I. So these are the only two answers that you can get. Is either you get 1 or minus 1, or you get I or minus I. Now notice that anytime the power is an even number, we must get a number. So it's either we get I or minus. Even number, we get what? 1. Sorry. You must get a number. Even number, you must get either minus 1 or 1. But if it's an odd number, you will get either I or minus I. Okay? So note that whenever n, if I have I raised to power n, and then n is even. N is even. N is what? Even. If n is even, then the only thing we can get is what? I or what? Minus I. Okay? So you notice that if n is now odd, if n is odd, then the only thing you get is what? 1 or minus 1. Okay? So the problem now is, when do we choose I and when do we choose minus I? Or when do we choose 1 and when do we choose minus 1? So when do we choose the negative or the positive? So we choose it by, if we divide that I by 2, if I have I, after knowing what you will do, if you divide it by 2, then you check again. If that n divided by 2 is odd, sorry, is even, if it is even, then we take the positive. We take the positive. So, but if it is odd, if n over 2 is odd, okay, then we take the negative. Okay, so take note of that. So that means if I have I raised to the power 5, the first thing I will check is 5 even or odd? 5 is odd. So since 5 is an odd number, sorry, I switched it. Sorry, this is 1 or minus 1. So why this is I or minus I? Sorry about that. So if it is even, I'm expecting 1 or minus 1, like we saw here. Even, minus 1, even, 1. So odd, if it is odd, I'm expecting I or minus I. So since 5 is an odd number, I know I'm expecting I or what? Minus I. I will now say 5 divided by 2. Please, what we are taking must be an integer. It must be a whole number. So this is equal to what? This divided by this will give you what? 2.5. We don't need the decimal part. We only need what? The integer part, which is the whole number. So, and you see that 2 is an even number. So since it's an even number, I will take what? The one that is positive, which is what? I. You understand? So if you have I raised to power maybe 8, for example, I raised to power 8, I will ask myself, is 8 even or odd? If you notice, you see that 8 is even. So since 8 is even, I'm expecting 1 or minus 1. So now, which one do I choose between them? I will say 8 divided by 2. And 8 divided by 2 give you what? 4. And 4 is what? An even number. So since it's even, I will take positive. Okay? So now, what about I raised to power 10, for example? If you see I raised to power 10, you see that 10 is what? Tell me the answer in the comment section before I solve it. So try it and tell me the answer in the comment section. Okay, 1 minute. So it's simple. So 10 is what? Even. So since 10 is even, I'm expecting 1 or minus 1. I will now say 10 divided by 2. 10 divided by 2 is 5. And 5 is what? 5 is what? Is it even or odd? 5 is what? Odd. Since 5 is odd, my answer becomes the negative 1. Okay? As simple as that. So if you have I raised to power 43, for example, you ask yourself, 43, is it even or odd? Or you tell me the answer in the comment section before I solve. Okay? Ask yourself, 43, is it even or odd? 43 is what? Odd. So since it's odd, I'm expecting either I or minus I. I will now say 43 divided by 2. 43 divided by 2 give you 22. 22.5. We don't need the point, so 22. Is 22 even or odd? 22 is even, so I will take the positive one. So the answer to this, I raised to power 43 is equal to what? I. Okay, as simple as that. So you've learned that. So that is basically the operation of iota. And then you should know that anytime I multiply each other, it's going to give you what? -1. Why? Because I squared is what? -1. Okay, so that's basically what you need to know about iota. So now let's now go to other things. So a subheading you write for me is equal complex number. Equal complex number. Now, when do we say that two complex numbers are equal? Okay, you will say that two complex numbers, right? Two complex numbers, a plus bi and c plus di are equal. They are equal if and only if. The only condition they will be equal is that if the real part a is equal to the real part, and then the imaginary part b is equal to the imaginary part. Sorry, a, the real part, is equal to c, the real part, and the imaginary part b must be equal to d. So that is when we conclude that what a complex number uh, is equal. So the only way they will be equal is if the real of this one is equal to the real of this one, and the imaginary of this one is equal to the imaginary of this one. So we can prove that. Let's check if it is true. To prove it, we say that a plus bi is equal to c plus di, right? So now let us collect like terms. If you don't have I, come to this side. So I have a minus c is equal to what? This one moving to this side, you have what? Di minus bi. Okay, so therefore a minus c is equal to what? D minus b all I. Okay, so now let us square both sides and see what is going to happen. If I square both sides, I'm going to have a minus c all squared is equal to d minus b I. Okay, d minus b I like this, then all squared. So this is now a minus c all squared is equal to, now remember that I squared will give you -1, so this is minus into d minus what? B all squared. Okay, now this one can now come to this side to have that what? A minus c all squared plus d minus b all squared is equal to 0. Now, remember that the square of any number at all must be positive. The square of any number at all must be positive. Even the square of -3 must give you a positive number, 9. Okay, so the addition of two positive numbers must be positive. I hope you know. And the only way you will add two positive numbers, you will get 0, is that both of them must be 0. The only two positive numbers, in fact, the only two numbers you will add, the only two positive numbers you will add and you get 0 is 0. So that means this first one is 0 and the second one is 0. So from this condition, you will see that a minus c all squared is equal to 0, and what? D minus b all squared is equal to 0. If I take the square root of both sides, I will see that a minus c is equal to 0 and d minus b is equal to 0. So this one crossing here, you see that a is equal to c and what? D is equal to b. So you see that it is proven. So the only reason two complex numbers can be equal is if the real part is equal to the real part and the imaginary part is equal to imaginary part. So take note of that. Okay, so now the next thing we'll talk about is addition and subtraction of a complex number. So addition and subtraction, all these things I'm teaching is a revision of what I have taught in my video on complex number. I have a full playlist on complex number. Maybe I'll drop the link in the description, and then or you go to the playlist side, you will see it there. Okay, so now, so the next one is addition and subtraction of a complex number. Okay, so now if I have let's say z is equal to a plus bi, okay, then let's say z1 and z2 is equal to maybe c plus di. Now, anytime you want to add a complex number, maybe you want to add z1 plus z2, okay, which is to add a plus bi, then plus c plus di. Now, the way we add complex number is that the real part we add the real part, then the imaginary part we add the imaginary part, we add the it. So that is the only way we add a complex number. The same thing is applicable to subtraction. That's how we subtract a complex number. Okay, the real, in fact, you do it like like terms. This one that does not have I, we add the one that does not have I. The one that has I, we add the one that has I. So an example, just one example. Z1 is equal to maybe 2 minus 3i. And then Z2 is equal to 5 plus I. Then I say we should find Z1 plus Z2. So which is what? 2 minus 3i plus 5 plus I. You will see that what I will do, this one that does not have I, we add this one that does not have I, which is what? 2 plus 5. Okay? Then plus the one that has I, which is what? In fact, even if you don't want to do it this way, just add it normal, straight up. So you don't have I, you don't have I. This plus this is what? 7. You have I, you have I. Minus 3i plus 1i. There's invisible one here. Plus 1i will give you minus 2i. So that is the answer to that. So now let us get z1 minus z2 in subtraction. So we have 2 minus 3i, okay, is subtracting 5 plus I. So this one is that the same thing applicable. It's either you open the bracket here and do your normal arithmetic, or you take it one after the other. You can say 2 that does not have I minus 5 that does not have I will give you minus 3. Then minus 2i minus I, because minus plus is minus. So, or the best thing is even to open the bracket. So you have 2 minus 3i. This time this will give you minus 5. This time this will give you minus I. So which will give you this 2 minus 5 will give you what? Minus 3. Minus 3 minus 1 will give you minus 4i. Okay, so that is basically how to add and subtract a complex number. So now let us get to multiplication and division of a complex number. Okay, we are moving gradually. So multiplication and division of a complex number. Okay, multiplication and division of a complex number. Okay, now basically, how do we multiply a complex number? Let's first of all talk about the multiplication. If I have that z1 is equal to a plus bi, then and I have that z2 is equal to maybe c plus di. I want to multiply z1 multiplied by z2. So this is a plus bi. Put it in bracket. You know that bracket means times. Then c plus di. Remember, just do the normal way we do multiplication. Okay, the normal way we multiply. That is, a will multiply everything, and then bi will multiply everything. So a times c will give you ac. A times di will give you adi. Bi times c will give you what? Bci. Then bi times di will give you what? Bdi squared, right? Because b times d will give you bd. I times I will give you I squared. Okay, I don't know if my writing is too small. I squared. Sorry about that. So now, once you are done, you're going to have that this is AC plus this is AD plus BC. They both have I in common. So I'll add the like terms. So remember that I squared is minus 1. So BD times minus 1 will not give you minus BD. Okay, so you now see that I have the real part and then I have the imaginary part. So the real part is AC minus BD is the one that does not have I, plus the one that has I is AD plus BCI. So this is the real part, this is the imaginary part. So that is basically how to multiply a complex number. So one example, just one. Z1 is equal to minus 3 plus 2i. Then Z2 is equal to maybe 1 minus I. Okay, so we'll now say we should multiply Z1 multiplied by Z2. So we're going to have that this is minus 3 plus 2i multiplied by 1 minus I. Okay, so this will give us minus 3 times 1 will give you minus 3. Minus 3 times minus I will give you minus times minus. First of all is plus. 3 times I will give you 3i. Okay, then plus 2i times 1 will give you plus 2i. Then plus 2i times minus I. First of all, plus times minus is minus. 2 times invisible 1 is 2. then I times I will give you I squared, or rather I times I will give you minus 1. Remember that anytime I times I told you before that I times I must always give us minus 1, does not change. Okay, so this will now give us minus 3. This 2 is giving us 5i, then minus times this will give you plus 2. So I'm having now minus 3 plus 2 give you minus 1, then plus 5i. So minus 1 is the real part, and then 5i is the imaginary part. Okay, so that is basically that for multiplication. So now let us move to division of a complex number. Now the division of a complex number will take us to what we call rationalization of a complex number. Why? Because it is an abomination, it is not proper, it is absurd to leave a complex number at the denominator. So anytime you see a complex number at the denominator, we rationalize. Rationalization will take it out of the denominator. So for example, if I have a plus bi, immediately I see I at the denominator, what will I do? I will rationalize. So it will now be a plus bi times that I over I. Some people will do times bi over bi. Some people will do like this, a over bi. So you now have that this is a over bi times the same bi over bi. You will get the same answer because b can take care of b. You will get the same answer. Okay. So this one will give you, this time this to give you ai over, this time this will give you, first of all, b times invisible 1 is b. Then I times I will give you I squared, and I squared is minus 1. So this is basically ai over what? Minus b, which is what? Minus a over bi. So another way, the shortest cut to rationalizing a complex number that looks like this is just to put minus, to bring the I up and take the negative of it. So for example, if I'm asked minus 3 over 2i, so what I will do is just bring the I up. I will take the negative of what I have here and then bring the I up. Okay, so you bring the I up, you take it negative, so, or change the sign. So okay, I can just say 3 over 2, bring the I up. This was negative initially, so it will now be positive. You understand? So that is basically the shortest cut to that. So if I have maybe 2 over I, so this is something as what? 2 over 1, bring the I up, then change the sign. So which will give you just minus 2i. As simple as that. So 1 over 3i will give you what? 1 over 3, bring the I up, then this was positive, it will not be negative. So that is the shortcut to that, okay, when it is in this form. So another way is when it is in an incomplete complex number form. For example, if I have a over maybe or rather c over a plus bi. So in this case, we apply rationalization of sort, the same thing we did in rationalization of sort. If you don't know about sort, you can watch my video on sort. Go to the playlist side, you will see my full video on sort. Okay, now this will take us to conjugate of a complex number. Now the conjugate of if I have a complex number z is equal to maybe x plus yi, its conjugate is written as z bar like this. This is what we know as the conjugate of a rational number. So z bar simply means change the sign of the imaginary part. Change the sign of the imaginary part. So this is going to be x minus what? Yi. So this is the conjugate of this. Sometimes lecturers will want to deceive you by, if you have z, they will now write it as minus maybe 2i plus 5. Students will now rush and say that the conjugate of this thing is z bar will now be minus 2i. They will just change the sign in the middle, minus 5. This is wrong. Okay, we are not interested in the real part. It's the imaginary part we're interested in. So the answer to this is supposed to be change the sign of this from negative to now positive. Then the other one remains the way it is. Okay, or rather, instead of making mistake, always arrange a complex number in the form of the real part must come first before the imaginary part. So if a lecturer gives you z is equal to minus 2i plus 5, so change it to normal complex number as z is equal to 5 first, then minus 2i. Okay, so that if you now want to get the conjugate, it will now be what? 5 plus 2i. So which is exactly the same thing here. Or you go straight and change the sign of the imaginary part. So that is what we mean by the conjugate of a complex number. And don't forget that it is always represented with what? A bar on top. A bar on top. So they may not write it for you, get the conjugate, they'll just say Z bar. So whenever you see bar on top of Z, know that they are talking about the conjugate of a complex number. Okay, so with that being said, the conjugate is what will help us to rationalize any complex number in this form. So what do? We rationalize using the conjugate. If you can remember in SOLD, the same thing is applicable in SOLD. Whenever a SOLD is written in the form of a plus maybe root b, we rationalize using the conjugate. Okay, we rationalize using the conjugate of this. So the same thing is applicable here. So we are going to do that. So this will now be c over a plus bi multiplied by the conjugate is what? A minus bi over what? A minus bi. So the conjugate is a minus here. So multiply with the same thing up and down. Now, anytime you are rationalizing either a solid or a complex number using its conjugate, the denominator must be difference of two squares. It's a must. The denominator must be difference of two squares. So for the numerator, do your normal multiplication. C will times this to have AC. C will still times this one to have what? Minus BCI. Okay, all over. The denominator must be difference of two squares. So the denominator must be the first person. In fact, the first person squared, then minus, then the second person squared. Okay? Or another easiest way is that the denominator, I tell students, is to make it easy for you. The denominator must always be everybody multiply your lookalike. Just multiply your lookalike everybody in the denominator. That's what I normally do. So a looks like a, so a times a, first of all, I have a squared. Okay, minus times plus is what? Minus. B times b is b squared. I times I is minus 1. So you still get the same answer here. So this one will be AC minus BCI. BCI all over A squared. Then I squared is minus 1. So minus 1 times this will give you plus B squared. So this will now be the same thing as what? AC plus BCI all over. Minus times minus is plus. So this is A squared plus what? B squared. So for the denominator of rationalization, any rationalization, okay, of this form must be each person multiply your lookalike. A will multiply A, plus will multiply minus because they are the same thing. So B will now multiply B, I will multiply I. So I'll just give one example to that, then we continue with what we have. All these things, I've explained it in the full video, the full playlist on a complex number. So if I have a question, 2 plus I all over 3 minus 2I. Okay? So to solve this is in this form. So we are going to rationalize. First of all, what is the conjugate of the denominator? The conjugate of the denominator is, since it is minus in the I, so I'm going to take it to now be plus. Change the sign of the imaginary part. So this is now what? 2 plus I all over 3 minus 2I. Then times what? 3 plus 2I over the same 3 plus 2I. Okay? I told you in the numerator, you just do your normal multiplication. But in the denominator, remember it must be difference of two square. So that is what to make it easier for you. But if not, do the normal multiplication in the numerator, equally do the normal multiplication in the denominator. You must get the same answer. Okay? But to make it faster, is to take this one I'm telling you. So let us do the normal multiplication for the numerator. So 2 is going to multiply everything, and then I will multiply everything. So let's go. 2 times 3 is 6. 2 times 2 will give you what? 4I. I times 3 will give you what? 3I. I times 1, there's invisible 1. 1 times 2 is 2. Then I times I will give you minus 1 multiply like this. Okay? Because it's attached. So you attach the minus 1 like that. So I told you in the denominator, let everybody multiply their lookalike. So first of all, 3 times 3 is 9. Minus times plus is minus. 2 times 2 is 4. I times I is what? Minus 1. So that is how you do that easily. So this will give you, this is now minus 2. So 6 minus 2 will give you 4. 4 plus 3 will give you 7I all over. 4 times this minus 9, this will give you plus. So 9 plus 4 will give you 13. So we don't leave it like this. So we separate it to be what? 4 over 13, the real part, plus 7 over 13, I, the imaginary part. So that is how you do that. Okay, so that is basically that for multiplication and division of a complex number. So we now move to forms of a complex number. Forms of a complex number. Okay, remember we've not even started the complex variables. We are still on a complex number. Okay, so forms of a complex number. Forms of a complex number. Okay, now basically a complex number can be in, do I say 3 or 4 forms? Okay, let's use 4, but the normal one is 3. I just want to add the logarithm form to make it 4, but it's always 3 anyways. So but let's use 4. So the forms of a complex number, the first one is called the XYZ, or the rectangular form, or the Cartesian form. We call it the Cartesian. I think it's either one S or double S. So check it out. Cartesian or rectangular. Rectangular form. Okay, which is the XYZ form. Sorry, XY form. So in this one, we write a complex number as Z is equal to what? X plus YI. So this is called the Cartesian or the rectangular form of a complex number. Okay, so the second one is what we call the polar form. The polar form of a complex number. So the polar form of a complex number is given as Z is equal to R in bracket of what? Cos theta plus I sine theta. Okay, so this is the polar form. Okay, then the third one, you see that we have introduced two parameters, R and theta. So where R is what we call as the modulus of the complex number, called mod Z, or absolute value of Z. This could be the modulus of a complex number. So they can represent the modulus of a complex number with what? R, or with mod Z, or absolute value of Z, like this. So all of them are still the same thing, modulus of a complex number. So how do we get that? If we have our XY plane like this, and then this is my complex number this way, okay, and then I have that this is our R, okay, and then I have, let me trace here to be the Y part, and then here to be the X part, and then here is 90 degrees. So if I apply Pythagoras theorem here, you see that to get our R will be R squared is equal to what? X squared plus Y squared. So R becomes what? The square root of what? X squared plus Y squared. So to get the modulus of a complex number, the formula is given as the square root of X squared plus Y squared. Okay? So don't forget that X is the real part, and then the Y squared, the Y is the imaginary part. Okay? So with this, so the next thing is that here is my theta, the argument. The theta is called the argument. So our theta is known as what? The argument of Z, arg Z. And if you use your SOHCAHTOA, you see that this is opposite over adjacent. So I'm using tan. So tan theta is equal to opposite Y over adjacent X. So theta will now be what? The tan inverse of Y over X. So my theta, the argument of Z, sometimes called arg Z, is what? Is tan inverse of what? Y over X. Okay, so that is that. So anytime you are asked to express a complex number from the Cartesian form to the polar form, all we need is to get the modulus, and then we get the argument, then we put it here. Okay, so we're going to do an example to that. So now the third part is what? The third part is what we call the exponential form. Exponential form. Now for the exponential form, we have that Z is equal to R exponential I theta. Why? Because exponential I theta is the same thing as saying cos theta plus I sine theta. Okay, so to express it in exponential form, we say that what? Z is equal to R exponential I theta. So the fourth one I was talking about is the logarithm form. Logarithm form. Okay, so the logarithm form is that we have that log Z. Log Z is something as saying log X plus YI, right? YI, because my Z is something as x plus yi. So if I take the normal method of logarithm, which is what brought about plus, is it possible? Yes, it's possible because I know that log a plus b plus log b is equal to log a plus b. Sorry, log a. Is there any way we can separate this? Is it possible to separate? Whew. Okay. So what are we going to do? Okay, see what we are going to do now. Let us take the modulus, the polar form of it. So this is something that's saying log. The polar form is r in bracket of cos theta plus I sin theta. Okay, so which is something that's saying what? Log r plus log what? Cos theta plus what? I sin theta. Right? So so that is basically that. That is basically that. Or another way is to take the exponential form. So if you take the exponential form, we're going to have log r exponential I theta. I think this one is better. Or from here, self. From here, we know that this is what? Log r plus log. Remember, I told you that this thing means the same thing as exponential I theta. So this is exponential I theta. So according to logarithm, this I theta can come to the back. So this is now what? Log r plus I theta log e. And then you know that log e, the base is, this is natural log we are using. So the base is e. So log e base e, when the base and the log are the same thing, the answer is 1. So log e base e is 1. 1 times this is remaining only this. So I'm having that this is what? Log r plus what? I theta. So you see that the imaginary part is your what? Log r. Why the, the real part is your log r. Why the imaginary part is your theta. And remember what is theta? Theta is what? The tan inverse of y over x. So this is something as what? Log. Remember that your r is the square root of what? X squared plus y squared. And then I have I, then tan inverse of what? Y over x. Okay? So that is how to express a complex number in logarithm form. Okay? So that is that. But that is not the main. This one can be derived, normal derivation. So the main thing is just to know the Cartesian form and the polar form. With the Cartesian and polar, you can get the exponential and the logarithm form. Okay? So that is that. So the next thing we will now talk about, the next thing we will now look at now is what's the next thing to look at? Okay, I'm coming. So let's give an example to that. How to express a complex number in all these forms. Okay. So one example, just one, because I've done a full video on these particular things. So I'll just be giving just one example to illustrate what I'm saying. Okay. So just example one. So let's say let z be equal to, what do we use? Okay. We're going to use, let me find something that will give us a normal, okay. So let's say 1 plus I root 3 or root 3i, anyone. Okay. So now we have this. So we want to express this in, you know that this is already in what form? In Cartesian form or the rectangular form. So we want to change it to what? We want to change it to the polar form, change it to exponential form, change it to logarithm form. So we're changing it to the 3 forms that are remaining. Okay. So the first one is to change it to polar form. So changing it to polar form, I told you the formula is that z is equal to what? R in bracket of what? Cos theta plus I sin theta. So the only thing I need is our r and theta. So to get my r, I know that r is equal to the square root of what? X squared plus y squared. So r is the square root of, remember that this is your x and your root 3 is your y, because this is what? X plus yi. Okay. Or iy, anyone. So this is 1 squared plus root 3 all squared. So r will now be equal to what? The square root of 1 plus 3. So r is equal to the square root of 4. So r is equal to 2. I've gotten my r. So the next thing to get is our theta. I know that theta is something as saying argument of z. And the formula is what? arctan or tan inverse of y over x. So theta is always what? Tan inverse of my y. My y is root 3 over my x is 1. Okay, so which is what? Theta is now the tan inverse of just root 3. And tan inverse of root 3 is 60 degrees. But in polar form, we don't use degree, we use radian. So how do we convert to radian? Remember, to convert degree to radian, I have 60 degrees. To convert it to radian is simply add pi to it and divide by 1/8. Very simple. That's how to convert degree to radian. So attach pi to it and then divide it by 1/8. So reduce these two to the lowest. To reduce it to lowest, 0 taking care of 0, 6 here is 1, 6 here is 3. So this is basically pi over 3. So 60 is pi over 3. So this is same as what? Pi over 3. So my answer, the polar form, is now z is equal to r, which is 2. R in bracket of what? Cos pi over 3 plus I sine pi over 3. Okay? So that is basically that. Now, another important thing, okay, this is the polar form. So to express it in the exponential form, we have that what? Z is equal to what? 2 exponential what? Pi over 3i. Because this is what? R exponential I theta. So that is basically the expression in exponential form. So in logarithm form, we know that it will now be what? Log r plus what? I theta. Don't forget, which is what? Log, our r is 2. Log 2 plus what? I pi over 3. Pi over 3. Or pi over 3i, anyone. So that is basically how to express it in a logarithm form. So that is that. Now, another important thing I want us to look at is the concept of even and odd function. The concept of even and odd function, because it will play a major role in this your polar form if you now have a negative number as your argument. So you need to know what we call what is it called? We need to know about odd and even function. Okay, so let's talk about odd slash even function. Even function. So now, a function is said to be odd if, for odd function, a function is said to be odd if f of minus x, that the minus will come outside to be minus f of x. So we call it odd function. Odd function. So, but if f of minus x, the minus disappears to have f of x, we call it that it is an even function. Okay? So an example to that is, if I have that y is equal to maybe x squared plus s squared plus x, for example, s squared plus x. So let's check if this thing is an even function. So y is equal to f of x, y which is equal to f of x, a function of x. So let's check if it's an even or odd function. If I take f of negative x, that means anywhere I see x, I'll put negative of x. So which is what? Negative x squared plus what? Plus what? Negative x. So this is giving, this will be out. So I have x squared minus x. So you see that this thing cannot be expressed in any of these. It cannot be expressed in either of the two. So it is neither odd nor even. So this thing is trying to show us that if something is not even, you cannot conclude that it is odd. If it is not even, tell us that it is not even. If it is not odd, tell us that it is not odd. Don't say that because it is not even, then it becomes odd. No. So, but you should know that, take note of, if it is polynomial, if all the powers are the same, if all the powers are all even number, then it's definitely going to be an even function. But if all the powers are odd number, it is definitely be an odd function. But if it's a mixture, then it will not be any of them. Okay, so an example to that is that if I have that f of x is equal to maybe x4 plus x squared, or plus 2x squared, anyone, plus 2x squared. Okay, so let's check if this is even or odd. So we'll take f of negative x, so which is what? Negative x raised to power 4 plus 2 into negative x raised to power 2. So this is something as the minus. When the power is even, the minus will go out. So this is x raised to power 4 plus, when the power is even, the minus will disappear, 2x squared. You see that now, this is my f of minus x. You see that my f of minus x is giving us the same thing as f of x. You see that? So this is you conclude that this is an even function. So this thing is even, is an even function. Okay. So another example is that if f of x is equal to maybe x cubed minus x, something like this. So let's check if it is even or odd. I will take f of negative x. That means anywhere I see x, I will take negative of it. So this is negative x raised to power 3 minus into negative x. So you notice that if the minus, if the power is an odd number, the minus will remain. So this is something as minus x raised to power 3. Minus minus give you plus x. So if I bring that minus outside, I'll have minus taking care of this. I'm having x raised to power 3. Minus into this will have minus x. So this is basically negative of, remember that this person is the same thing as f of x. So negative of f of x. Okay, so you see that our normal f of minus x is now giving us, the minus came outside. So this is basically what? An odd function. Okay, so why are we studying this? The reason is that you should know that is only cos in trigonometry. Is only cos that is an even function. The rest is an odd function. Please note, only cos is an even function. The rest is an odd function. So which means that if I have sine negative theta, that because sine is an odd function, the minus will come outside. So it's written as minus sine theta. Okay, but if it is cos negative theta, the minus will disappear because cos is an even function. It is written as cos theta. So take note that it is only cos that is what? An even function. Okay, so having known this, it will now help us in the next example that we are going to solve in polar form. Okay, next example in polar form. So all right, so now example. So we now have that. Let's take that z is equal to, let's use the same thing we used before, but in this case now let's change it to minus root 3i. Okay, let's see why we are studying this even and odd function. So to change it to polar form, I'm going to do only the polar form so you can do the rest. So to change it to polar form, I need my r. My r becomes the square root of what? X squared plus y squared. So my r is basically the square root of what? 1 squared plus minus root 3 squared. So I'm having that my r is basically the square root of 1 plus 3. 1 plus 3. So my r is equal to square root of 2, square root of 4, which is what? 2. Okay, so I've gotten my r. So the next thing to get is our theta. So our theta is equal to what? The arctan or tan inverse of y over x. So my theta is what? Tan inverse of, remember that theta can be called arg z, argument of z. Sometimes they don't ask you theta, they will just say find argument of z. Okay, so this is minus root 3 over 1. So basically my tan inverse will now be what? Minus root 3. And minus root 3 is what? Minus 60 degrees. Remember, we are not using a degree but radian. So it will now be minus 60. Attach pi to it and divide it by 1/8. So reduce to the lowest to have minus pi over 3. Now, this, if it is objective that you are writing, I will show you that this thing will have, let me say, different two answers. So, or three answers. The first answer is that your z is equal to r. Remember the formula. R what? Cos theta plus I sin theta. So therefore my z will now be r in bracket of cos minus pi over 3 plus I sin the same minus pi over 3. So the examiner might be lenient, might decide to just leave the answer like this. That is one of the answers. So the second answer is that since cos is an even function, the minus here can disappear. So another answer, sorry, I have that my arrow is 2. Okay. Another answer here is that z is equal to 2 into, minus will disappear because cos is an even function. So it will now be cos pi over 3. Sine is an odd function, so the minus will come outside. It will now be minus I sine pi over 3. So this is another answer to this. So the third answer is let me show you the third answer. The third answer is anytime you are given a complex number like this and you want to find the argument, you can first of all represent it in your Cartesian plane. If I represent it in my Cartesian plane, okay, or my cardinal points, you represent in your cardinal point, you have that Your x is a positive number, so just draw a line on the positive side. Your y is a negative number, draw a line on the negative side. Okay, so you will now take the two of them. If I take the two of them like this, you see that this met, they met on, this is your first quadrant. You are moving anti-clockwise. Second quadrant. It's only in bearing that we move clockwise, but in trigonometry we move anti-clockwise. So this is third quadrant and this is fourth quadrant. Okay, so since this thing is in fourth quadrant, what do we do? So if you want to, we got that our theta is equal to negative 60. So for us not to use this negative, we change it to positive. How do we change it to positive? It's in the fourth quadrant. So since it's in the fourth quadrant, we add 360 to it. So the answer is same. So negative 60 is something as what? 300 degrees. So that's another way to do that. Okay, so since it's in the fourth quadrant. But if it's in the second quadrant, so in fact, the manipulation of changing it to positive is either you add 1/8 or you subtract 1/8. It's either you add 1/8 or you subtract 1/8. So depending on the quadrant, it will fall. So if it's in the third quadrant, for example, I have maybe minus 270, okay, or maybe minus 28, for example. No, 210. 210 is third quadrant. So minus 210. Now, minus 210 is in the third quadrant. We don't use 270 for any reason. I know that you know that the third quadrant is from 180 to 270, but with yes. If you add 90, yeah, 270. So we don't use 270 for any reason. So it's either you are using 180 complete circle or use half of the circle. So if you either use 180 half of the circle or use 360 complete circle. So we don't use quarter of the circle, no. So that's why we don't use 270. So what we do here is for this thing to be positive is either we add 180 to it or we add 360 to it. So any of the two. Okay, so take note of that. So if, for example, let's say that we have minus 1 plus root 3. Let's see what is going to happen. For minus 1 plus root 3, see that my x is negative here and my y is positive here. So this fell in the second quadrant. So since it's in the second quadrant, if I get minus 60 in the second quadrant, I will say, since it's in the second quadrant, I'll add 180 to it. So you see that this plus this will give you 120. And 120 is in the second quadrant because second quadrant is from what? 90 to 180. First quadrant is just from 0 to 90. For fourth quadrant is from 270 to 360. So that is why drawing this quadrant will help you get exactly what you are looking for. So in this case, 300. And 300 is correct. 300 is between 272 or 360 in the fourth quadrant. Before you can now change it to radian. How do you change it to radian? 300, attach pi to it, divide by 1/8. So reduce these two to the lowest to change it to radian. So that is if you want your answer to be only positive, depending on the examiner. So that's why I said that answer can have, the answer to that question can have like 3 answers. I get it now. So in this case, so you see that this take care of this. 2 here is 15, 2 here is 9, 3 here is 5, 3 here is 3. So I'm having 5 pi over 3. You see that? 5 pi over 3. So this is the same thing as another answer to this. Another answer to this can be z is equal to 2 into cos 5 pi over 3 plus I sine 5 pi over 3. So you see that the answers can be 3. It could be this one, it could be this one, it could be this one, depending. So that is that. So another thing is that what if it fell in the third quadrant, like minus I minus root 3, minus I minus root 3? You will see that drawing this thing is very, very important. Very, very important. You will see that I will have that minus and another minus. So this is third quadrant. You see that if you take the arctan of this, you get 60 degrees. But this 60 degrees is not in the first quadrant, it's not in the third quadrant. So you have to make it to be in the third quadrant by adding 180 to it. If you add 180 to it, it will now give you the exact degree. For that is the normal method to even use. You have to draw the Cartesian plane to know where your angle will fall so that you don't make mistake. So that is even the best way to do that. So you must draw it to check where your angle will fall, and then you know what you are using. So this plus this is giving us 240. So this is 240 degrees. So if you attach pi to it and divide by 1, it then reduce to the lowest. that will not be the argument you will use. So to drawing this thing is very, very important. So, and it is easy to draw. Just draw a mark on the negative, draw a mark on the positive, depending on what you're having. Then join them together to know in which of the quadrant it will fall, and then know your manipulation. The manipulation is what? Is either you add 180, or you add or you subtract 180, or you add 360 or subtract 360. Remember, we don't use 270 for any reason. Okay, so that is basically that for polar form. So the last thing we're going to talk about before we call it a day for this particular thing is the Moivre theorem. Okay, the Moivre theorem. Oh, okay, the Moivre theorem. I'm thinking to, if I can just stop the video here and then do this de Moivre theorem in our next video. So I think it will be better, because this is already 1 hour video. So thank you very much for watching this particular one. Don't forget to like our video, share to your friends, and drop your comments. Okay, so see you in the next video.